In this video, we are going to see about the characteristics of TE and TM waves. What do you infer from these diagrams? Examination of field equations of TE and TM waves shows that for each component of E or H, there is a sinusoidal or cosinusoidal standing wave distribution across the guide in the x direction. In y direction, by assumption, there is no variation of either magnitude or phase of any of the field components. Thus, an xy plane is an equiphase plane for each of the field components. All these equiphase surfaces progress along the guide in z direction with a velocity v equal to omega by beta, where beta is the phase constant. The propagation constant h square equal to gamma square plus omega square mu epsilon, and we know that h equal to m pi by a. Therefore, gamma equal to square root of m pi by a square minus omega square mu epsilon. At high frequencies, omega square mu epsilon is greater than m pi by a square. Therefore, equation 2 becomes gamma equal to alpha plus j beta equal to square root of minus of omega square mu epsilon minus m pi by a the whole square. By equating these equations, we get alpha equal to 0 and beta equal to square root of omega square mu epsilon minus m pi by a the whole square. As the frequency is decreased, a critical frequency is reached at which omega c square mu epsilon equal to m pi by a the square. So omega c square equal to 1 mu by a m pi by a the whole square, and we get fc equal to m divided by 2a root of mu epsilon after substituting omega c equal to 2 pi fc. For each value of m, there is a corresponding cutoff frequency below which wave propagation cannot occur. The wavelength lambda, the distance required for the phase to shift through 2 pi radians, is a wavelength. Lambda equal to 2 pi by beta, and substituting the value of beta, we get lambda equal to 2 pi divided by square root of omega square mu epsilon minus m pi by a the whole square. Phase velocity or wave velocity is calculated from the equation v equal to omega by beta. After substituting the value of beta, we get velocity of phase velocity equal to omega divided by square root of omega square mu epsilon minus m pi by a the whole square. Assessment. What is cutoff frequency? The relationship between phase velocity and group velocity is define guide wavelength. Fourth one is what is the relationship between cutoff frequency and cutoff wavelength. So in this video we studied about the characteristics of transverse electric and transverse magnetic waves, and also calculated the values of phase velocity and wavelength lambda. Thank you. The next slide we are going to see about the rectangular waveguide and circular waveguide and its TE and TM characteristics.